We often view it as an immovable symbol, but this structure shouldn't remain like that forever. 1,000 tons of reinforced concrete defy gravity at an altitude of 700 meters above sea level, atop a mountain peak, where winds can exceed 200 kilometers per hour. To understand the grandeur of this structure, we have to go back to 1921. Brazil wanted a symbol for its centenary celebration of independence. Corcovado Mountain, also known as the Hunchback, was the obvious choice for the location. But the craziest thing is its structure. We're talking about an isolated granite tower surrounded by tropical rainforest and ravaged by Atlantic storms. Engineer Heitor da Silva Costa won the competition, but his first design was completely different. He envisioned a Christ holding a cross and a globe. However, initially, the criticism was fierce. They sarcastically called it Christ with the ball. This initial failure spurred Nemna Silva Costa to seek the perfect blend of artistry and technique. The final decision was brilliant. The statue itself would become the cross. An Art Deco design, minimalist and modern, but it faced a huge technical problem. How can a cross-shaped structure withstand such strong crosswinds? In the 1920s, the choice of materials was a major dilemma. Many advocated the use of steel. It was similar to the case of the Eiffel Tower, but Silva Costa made an unconventional and risky choice at the time. Reinforced concrete. Steel, when exposed to the salty sea air, would require unsustainable maintenance and would rot within a few decades. Reinforced concrete is touted as the artificial stone of the future, but no one has ever exploited it to such an extent. The height required for such a complex work of art necessitated the calculation of the stresses. To Albert Caquot, one of France's greatest structural engineers, Caquot had to calculate the resistance not only to its own weight, 1,145 tons, but above all to wind pressure. Christ's outstretched arms act like a giant sail. In a storm, the pressure exerted on the structure reached hundreds of kilograms per square meter. Reinforced concrete provides the necessary stiffness, but it presents a challenge: how to ensure the concrete is poured evenly and without air bubbles at a height of 700 meters, in a place where the climate changes every 10 minutes. While the rock is being studied in Brazil, the aesthetic soul is taking shape in Paris. Silva Costa understands that to honor specific things, it required the touch of a talented artist. He chose Paul Landowski. Landowski was not involved in designing the Corcovado, but at his studio in Boulogne-Billancourt, Landowski created life-sized plaster models of heads and hands. The head is 3.75 meters tall. Each hand is 3.20 meters long. These models were divided into dozens of pieces, creating negative copies which were then transported to Rio de Janeiro. Upon arrival, these replicas, the voids were filled with reinforced concrete directly on site. It was the largest three-dimensional jigsaw puzzle in history at the time. Each numbered block must perfectly fit into the pre-existing metal frame inside. An error of a few millimeters at the base will lead to a height discrepancy of meters at the mountaintop. Try to imagine a construction site in 1926. There are no paved roads leading to the summit. The only means of transportation is the Corcovado Railway, a rack railway that opened in the late 19th century. Every gram of material, sand, cement, water, scaffolding, and plasterboard from Paris. They had to travel in small carriages. Space on the mountaintop was very limited. Storing large quantities of materials is impossible. A construction site must operate like a perfectly synchronized machine. What arrives in the morning must be assembly, or pouring takes place in the evenings. The workers live in extreme isolation. Often shrouded in clouds, the scaffolding becomes slippery and difficult to see. Despite the complete lack of modern safety harnesses and the hazardous nature of the construction site, not a single victim was reported during the 9 years of construction, a feat of engineering. At the time, this was almost a miracle. We often see Christ as a solid rock, but technically, it's a hollow 12-story building. Inside is a complex structure of The columns and crossbeams are designed to distribute the load toward the foundation. They are attached directly to the granite rock of the mountain. An internal metal staircase allows access to the entire statue, from feet to hands and head. The corridors are narrow and cramped. On the 4th floor, at chest level, the structure opens up to the center of the project. Silva Costa was so meticulous that he had a small heart-shaped protrusion cast. From the inside out, everything is finished with the same meticulous detail as the rest of the statue. The only detail invisible from the ground, a secret marker for future engineers. Reinforced concrete is very strong but porous and will crack over time due to thermal stress. Silva Costa was looking for a tiling material that would last a lifetime. He found the answer in steatite, also known as steatite stone. Soapstone, a type of stone abundant in the quarries of Minas Gerais, has a unique characteristic. When first mined, it is as soft as talc powder, but becomes extremely hard and waterproof after exposure to environmental elements. But how do you cover such a curved surface and such a complex surface? The solution is a marvel of handcrafted micro-engineering. The stone was cut into 6 million small triangles, each side measuring 3 centimeters and 1 centimeter thick. These triangular pieces were not glued onto the statue individually. That would have been impossible. Silva Costa mobilized parishes in Rio. Thousands of women glued the pieces onto sheets of linen paper. These sheets of paper were then carried to the mountaintop and pasted onto the freshly laid cement like a kind of mineral wallpaper. Many women wrote their husbands' names on them. Children, or their secret desires, are reflected on the backs of the chess pieces. Technically speaking, Christ is not gray. A shell of millions of rock fragments reflects different light every hour, all day long. Protect the inner steel armor from the deadly humidity of the forest. As the tallest structure on an isolated mountaintop, it was always a target for the enemy. Lightning. During the rainy season, Corcovado is the epicenter of extremely powerful electrical discharges. To prevent the statue from exploding upon impact, an advanced protection system has been designed. The entire internal structure functions as a Faraday cage. Lightning rods are integrated inside, along with the top and arms. The system discharges electricity through a thick layer of metal armor covering the granite foundation. However, the power of tropical lightning is characterized by the fact that soapstone is often vaporized by its impact. In 2014, a powerful blow destroyed his right thumb. Technical repairs are a daunting task. They require specialized workers. These people, who were also professional climbers, had to rappel down from the top of the statue, step along its outstretched arms into the void, and recreate your fingertips with soapy water. It was quarried from the same original quarry in the 1930s and specially preserved for restoration purposes. On October 12, 1931, when the lights were first switched on, the world witnessed a work that was neither merely art nor engineering. The Christ the Redeemer statue, a marvel achieved despite the wind, altitude, and time. A colossal structure weighing thousands of tons, yet it appears as light as a feather thanks to its Art Deco lines and the incredible precision of its joints. It's more than just a monument. This is the result of 9 years of meticulous planning. Millions of stones were hand-glued, and a vision transformed a rugged mountaintop. It has become a global icon. The next time you see Christ, remember that hidden within him is. The outer stone shell conceals a reinforced concrete heart, redefining the rules of modern architecture. Technology is not just about numbers, but also about the courage to dare to dream. If you find this useful, technical knowledge interesting, and want to explore the secrets behind the world's greatest structures, please subscribe to the channel.